Today we'll be looking at applications of Newton's laws of conservation of linear momentum. We have discussed linear momentum. We have discussed Newton's laws of motion. But to refresh our memory, the Newton's laws of motion are, we mentioned three of them. Newton's first law, which states that a body will continue in its state of rest or uniform motion unless acted upon by external forces. The second law states that the rate of change of momentum is directly proportional with the applied force. And the third one states that for every action, there must be a reaction in the opposite direction. So let's look at a scenario where a gun is fired. That gun has mass, it has bullets with mass, and once the bullets goes out of the gun, they go with a certain velocity. And the person that fired that will experience a kind of a backward force. And that force is what we call the recoil force. Whereby the force that has propelled the bullet is what we call the propulsive force. So the total momentum as regards the gun and the bullets will be written as mv plus mv, as small letters, equal to 0, where they stand for the mass of the gun, the recoil velocity, the mass of the bullets, and the velocity of the bullets. So we can write this as mv equal to minus mv. So by the time you make the capital V the subjects, have that V will be equal to mv all over capital M. This is minus. So we have a problem here to solve. A gun of mass 5 kg fired a bullet of mass 0.01 kg with a velocity of 250 meters per second. Calculate A, the recoil velocity of the gun, B, the kinetic energy of the gun and the bullet. So let's appeal to this formula to solve this problem. We have m equal to minus this. So from here, we are to calculate the recoil velocity, which is v equal to minus mv all over capital M. So in this case, where the mass of the bullets is given as 0.01 kg. The velocity of the bullets is given as 250 meters per second. And then the mass of the gun is given as 5 kg. So we can calculate our V as minus 0.01 times 250 divided by 5 kg. So by the time we evaluate that, we now have, by the time you evaluate this, we have V will be equal to minus 0.503 meters per second. And that will be the recoil velocity. So let's look at the B part of the question, the kinetic energy of the gun and the bullets. So kinetic energy, that is the B part of the gun. We have mg v square g, and that's the formula we use. And based on the parameters given to us, the mass of the gun is 5 kg. We calculated the recoil velocity to be 0.50 meters per second. That is minus. So we can write this as half times 5 times minus 0.50 square. Of course, this is a negative value. So by the time we square it and multiply by 5, divide by 2, we'll have 0.625 joules. So next we'll look at the kinetic energy of the bullets, which is half mb v square b. So the mass of the bullets is given as 0.01, this is half, times 0.01 times the velocity of the bullet is 250 all squared. So by the time we square 250 multiplied by 0.01 divided by 2, we'll have 312.5. We'll have 312.5 joules.